Okay. In this video, we'll talk about Bayesian data types. And I want in this video to describe the Bayesian data types in a holistic way so that you have them ordered and um, com- um, the- arranged in your minds as in a hierarchical way. So you understand what is what and what comes from what. Okay? So let's start. What are Bayesian data types? Uh, Bayesian has two types of data: simple data or scalar data. This means one data that represent one variable or one data that represent one thing, one value, one state. The other type is category is a collection, also known as a container. And from the name container or collection, it means that this type contains something inside it. So it's a collection of it collects and aggregates some other data elements inside it. Okay, so these are the two data type categories: simple and container or collection. Okay, the symbol is divided into three types, subtypes, and collection is divided into three subtypes. What are they? The symbol, we have either a number, a truth value known as Boolean, or none or null. Okay, the second two are simple and easy. The none keyword or that type represents null value, simply null value. Okay, so you have a value or no value. Boolean values represent truth value, either true or false. We'll talk about Boolean and null by the end of this video. Now, numeric values fall into one of three subcategories. So, numeric, Boolean, none, three categories fall. The numbers are one of three subcategories. Either an integer number, a whole number, like 0, 5, minus 5, 10, minus 10, 100, etc. Or a floating or a decimal number with fraction, like 3.114, like minus 2 or 2 minus 2.5. These represent a number with a decimal point. And the word float comes from its representation. It's represented as a floating point, a point that floats on the line number. Floating point. Okay? The third type is the complex. If you have studied mathematics earlier, you know what complex numbers are. And simply, complex numbers are numbers which contain two parts: the real part, which we know, and the imaginary part, which represents the value of square root of minus one. It's written in the form of real plus imaginary dot j, not j, not dot j, sorry, imaginary j, like 2 plus 3j. Okay, so it means 2 is plus 2 is positive real component, and 3 plus 3 is a positive imaginary component. So it's a point here and Cartesian dimension. Okay, that was about the simple or scalar data types. Now, the collection data types or the containers, we have also three categories: a mapping category, or a set, or a sequence. Mapping is simple. Uh, it's a collection that maps something to something. So you can reach the value using a specific key. For example, your record in the school contains name, John Smith, age, 19, um, gender, male, address, 123 ABC Street, Connecticut, no, لا first, XYZ town, and then Connecticut. So key value. Okay, this is simply the mapping, and it's represented by a class called dict, short for dictionary. And for dictionary, you don't have, it's not mandatory to have the data collected. However, since Python 3.7, the requirement states keeping the order of the items entered um, if you want to iterate over them. But this is very, very, very advanced feature. Now, just remember that the dictionary does not necessitate ordering. Second is set. And a set, as we know in mathematics, is a collection of items that does not accept repetition. So every item is unique. So the set is represented by two classes, not only one class. Namely, they are set and a frozen set. The difference between them is that set is an unordered collection of unique items, as we expect. Frozen set is an immutable set. And here comes the new word, which is immutable. Immutable simply means a collection that after being created, you cannot modify. You can neither add an item, nor remove an item, nor replace an item, or change an item. Okay? So this is called immutable object. Everything, everything in a set is mutable. Everything in every object of frozen set is immutable. That means that once you create it, you cannot change it. Okay, what about sequences? Sequences are very nice and very, very useful and widely used items in Python. First, we have list and tuple. List and tuple are an ordered collection of items that keep a specific sequence, and you can reach every item by its index. So the first item, second item, third item, fourth item, until the last item. And both list and tuple, they accept to contain items of heterogeneous origin. That means they don't have to be of the same type. Not necessary that all of them are not all items in the list must be integers. So simply you can put things like your address, 123, ABC Street, XYZ city, city state. So 123 is a number. ABC Street is street name, string. We'll talk about string later. You can also add, then you forgot to say the number of apartment, so you can add it. Then apartment 3, we added already. Okay. So we have number, string, enum, or string. Okay. So what's the difference between list and tuple? The same difference. A tuple is immutable collection of items. So once you create a tuple, you cannot change it. While the list, once you create a tuple, you can still add, delete, or modify items inside it. Okay, so that was about list and tuple. What's next? String. String is an immutable sequence of characters, as we all know, like my name, Amr Ali Mukhtar Al-Husari. And every item is ordered. You must come in the same sequence, and you can each the first item, second item, any item if you want. For example, so my name is Amr, AMR. The first, the item number 1 is A, number 2 is M, number 3 is R. You are in Manchester, CC, so the first letter or item in Manchester is M, capital M, of course. Second is A, then N, then C, then H, then E, then S, then T, then E, then R. Cannot come Z, cannot come Z. R comes before E. This will be tumbled. Okay, so this is a string, and then string is also immutable. So once you create a string, you cannot change it. So if you want to change a string, what to do? We'll create a new string, but this is something else we'll talk about later. We talked about list, tuple, string. Next is byte array and bytes. Similarly, bytes array and bytes are mutable and immutable form of sequence of bytes. Bytes can be binary value that contains a number from 0 to 255. And in hexadecimal, they call it from 0 to FF, if you care about it. Anyway, so a sequence of bytes that can be anything. Can be an image, can be an executable file, can be database, whatever. And also the difference between byte array and bytes is that bytes is immutable. It's noteworthy here that bytes can come directly from string. And because the string is immutable, then bytes is immutable. Simple, straightforward. Okay. Last and not least, range. Range is a specific class generated by a specific function called range. It generates a sequence of number. And I use the word generate on purpose because this is called a generator function or a generator pattern. We'll talk about generator pattern when we talk about looping and iteration. So just remember the word generator, put in your mind, talk about later inshallah. In this slide, we represent the same previous slide, but in more visual description without much words. So Bayesian data types are either symbol or scalar, also known as scalar, or collection, also known as containers. The symbol data types are either numeric, Boolean, or null. The numeric value is either integer, whole number, float, decimal, or complex number. The Boolean is represented by the type bool. The null is represented by the type none. The collections are either mapping, set, or sequence. The mapping is represented by the class dict, short for dictionary, and set, which is either set or a frozen set. Frozen set is immutable. And the sequence is either list, which is mutable, or tuple, which is immutable, byte array, which is mutable, or bytes, which is immutable, string, which is immutable, and finally range, which is also immutable. If you notice here, of course, the red types are immutable in comparison to their mutable counterparts. Okay. Next, let's talk about the numeric data types in a little bit more details. We have all of course, passed high school, so we know what numbers, floats are, and decimals are, and what operations are. But let's see them from computer science perspective. So we have some operators. We'll talk today about the arithmetic operators and maybe the assignment. Yeah. The arithmetic operators are simply done to present the mathematical operations like multiplication, division, addition, subtraction, power. There are also two other operations which are the integer division and division remainder. We'll talk about that later when we talk about the operators, but they are simply what they are: a plus b, a minus b, a times b, a divided by b. Okay. Well, the next set of operators are the assignment operator. The first of them, of course, and their prototype is equals operator, which is assignment. let's say A equals 5, as simple as this. However, the rest of operators here are combined or composite assignment operators, which include one of the operators above, the arithmetic ones, plus assignment. So we have plus equals, minus equal, times equal, divide equal. They simply do the operation and assign the value to the left operand. So if I say A plus equals 1, that means sum A to 1 and put the value in A. A times equal 2, it means calculate A times 2 and then assign the result to A. So the assignment operator is again a composition of an operator followed by the assignment operator. Okay, we also have comparison operators: equals, not equals, greater than, less than, greater than, less than or equal, greater than or equal. This is how they are written, and I trust your intelligence to understand them. The rest of the operators we're not talk about. I'm going to talk about them here, but I keep this slide for completeness. So later, when you need them, you'll find them. Okay. What I here care about is general arithmetic operator rules. And the rules are very simple and interesting. Operators with all operands of type int produce int. So if you add 5 to 3, the result is 8. If you subtract 5 minus 3, the result is 2. 5 and 3 are integers. 2 and 8 are also integers. Straightforward. 5 times 3 is 15. Both are integers. The product is also integer. Nice? Okay, keep a point here. I'll talk about it later. Operators with at least one floating variable as one of the operands will produce a float. So 2.5 plus 5 plus 2.5 will not produce 8 anymore, will produce 8.5. So this is float. So if at least one of the operands is float, then the result will be float. The same for multiplication, division, etc., everything. And if one of them is complex, now I trust your imagination, what will be the result be? Simply will be a complex. So if all operands are int, the result is int. If all operands are float, the product is float. If all operands are complex, the product, the output is complex. This is nice rule that runs for everything except for division. Why? Because if you divide 5 by 3, the result is not, the result is, how much? 1.3, 1.2 1 and 2 thirds. Let's say 5 divided 5 by 2 over 2. The result is 2.5. So the result here is not int. Also, although both operands are integers, the output is not integer. The output here is float. Then how can we get the integer if we want? Okay, suppose that you and your friend are at your kitchen and you want to offer him to you have some apples and you don't have a knife, so you want to divide the apples you have on both of you. How many apples you have? 5. How many persons you are? 2. how can we divide them? You will take 2 apples, he will take 2 apples, and 1 apple will remain. There's another type of division. It's called integer division. In mathematics, also called floor division, which produces the floor of the product. So 5 divided by 2 as integer division without having a knife to divide the last apple will produce 2 as output of the division output, and 1 remains. So the remainder is 1. You can get these two values using specific operators, slash slash instead of slash. This will, when you divide 5 slash slash 2, will produce 2 integer, not 2.0 float. Okay? And always very important rule is that remember that division by 0 causes a runtime exception. So don't divide anything by 0. Agreed? Okay, let's go to next topic, which is very simple and straightforward. Now we talked about we talked about 3 types of simple types: numeric, Boolean, and null. We talked about numeric. Let's talk about Boolean and null. Boolean expression, Boolean value. The name comes from it's named after the French mathematician Georges Boole, who described an algebra based on 0 and 1 only. So 0 plus 0 equals 0, 1 plus 1 equals 0, 0 plus 1 equals 1, 0 times 0 equals 0, things like this. Okay, and later computer scientists find that this algebra is very nice and very useful to represent true and false, false and true, where 0 stands for false and 1 stands for true, which is very, very nice in computer science. So, and also in electric engineering. So we use the word Boolean and Boolean algebra and truth value interchangeably right now. So Boolean simply comes from the name bool, and a Boolean value is either true or false. The null type is the last one we talk about here in this video, which is a special type that represents the value null. The value null is represented by the keyword none. The none is actually a keyword, and the class name and the type, it's everything actually. And when you want to check something whether something is present or not, you can check using the operator is, and the operator is not. Don't use the operator equals or not equals. So you can say is none or is not none. Okay, this is about the Python data types, and I close in the video with this slide again. See you later in another video. Bye bye.